Hello, this is Dr. Yamada. In this video, I'm going to give you a quick tutorial for research project with eye tracking system. This system is a Tobii Pro Lab software. The scenario I'm going to go through is you collected data with the Tobii Glasses 2. So the very first thing you want to do is to open the Tobii Pro Lab software, which is different from the software you used for data collection. So make sure first, and on the left side, you create a new project for the very first project. And then again, the situation is you collected data, not from the computer screen eye tracking system, but the eyeglasses. So make sure to check the glasses and give a name of the project, and then hit create. So once you create the new project, then you actually don't see anything. So the very first thing you want to do is to import the collected file into this software. So click import glasses recording. The new window will appear. The file you want to pick is not any files, any folders here, but actually this one, project TTGP. And click open, and this will show you all collected data with eye tracking system. So let's say I just want to process this data, click the checkbox and import. Double click on that. It will open up the file. Let me go through some of the basic ones. So on this display is what I call event display, because you can create and mark different time points, or it will also show you the different time points when you collected data. So for example, by default, the logged events that I created during the data collection it's shown with this tick marks. If you synchronize with the externally controlled marks, then you actually check the sync events, and this will give you all the sync events you created. But for now, I'm going to uncheck that. Next, what I want to point out is this one. You can change the play speed, and then this is a volume, and this is a timestamp. You can actually type in a specific time frame, and this is a play and pause. Right, and what you see on this circle is the gaze. These are the path of those fixation points, and you see the arrows that you can jump. You can jump through different frames. On the right side column, those are the things you can manipulate. On the very first one is something, it's just a basic information you don't need. On the second one, gaze data, by default, if you open the project with the glasses, then the default filtration of the raw data is this IVT attention. You can change the filtration to a different one, for example, fixation, and you can consult on the Tobii the website. The difference between the fixation and attention filtration is that the sensitivity to define fixation is different. For this tutorial, I'm just going to use the fixation filtration. And time of interest or TOI is something I will explain later. And you can also look at the event section. By default, the sync events are not recorded here on the logged or logged. So if you use external trigger to synchronize with other system, for example, EMG, EEG, and a motion capture system, you want to click on that one. There are two different types of cameras that the Tobii glasses use. So one is to capture your eyeball movement so that you can record the gaze points, right? So the sampling rate frequency of the gaze point, you can choose when you collect the data, 50 or 100. Or the older versions there were 25, but right now it's a 50 or 100. The videos that you see, this is the same video that's you can find outside the classes to visualize where the participants are looking at. So this one, the frame rate is 25 hertz. So if you move frame to frame, it only moves every 40 milliseconds. So everything in between is lost. Well, when you actually look at the video, you can also zoom in and zoom out. So let's say you want to analyze the golf putting, right? And then one of the most important things I want you to understand is, I, so when I click through these arrows of this event display, the default display when you first open the file, a lot of people misunderstand these arrows are frame to frame analysis, but it's actually not. For example, when you look at this 3 seconds and 733, if you click on that, it jumps to 4 seconds, 4.6. It jumps to 5.227. It's not even equal interval because these arrows actually indicate the fixation point to another fixation point. More precisely, the mid portion of the fixation point to the next mid portion of the fixation. For example, if I move my cursor to this eye movement area, fixation was sampled for 26 samples, starting from the 2.963, right? So the frame that you see right now is the mid portion of the sampled duration of the fixation. So 26 divided by 2, 13th frame of the fixation. So if you move to the next fixation point, this was fixation sample 48 frames, right? So you divide by 2, so it gives you, it jumps to the time frame on the 24th frame of the fixation. So the mid portion of the fixation to the next mid portion of the fixation. That's what this arrows mean. So it doesn't give you any frame to frame equal interval analysis. Let's say you want to identify different phases of golf putting, right? I'm just going to arbitrarily define some of the different phases, right? So typically when participants do a golf putting, they look at the target, they move their fixation back to the area near the ball or club and look at the target, sometimes just once, sometimes twice, sometimes 3 times, moving the gaze back and forth between the target and the ball. For example, something like this. Look at the target, back to the ball, look at the target, back to the ball. So I want to determine the first time they fixated their vision to the target, which is over here. What I can do is I can create an event. You go to the right column and look at the event section. You click on the plus mark, and then you name it. And click OK. So then you created a new event. So this actually doesn't log this time frame. So what you have to do is once you create an event, you move the cursor to this one. You see a log, you click on that. Now, as you can see, the logged events, you just created the new marker on the timestamp.